Hi everyone, welcome. This time I'm going to show you how to create a new database in Patran, how to import a solid, and also to read the results that the software gives. Well, to start with, we are going to create our database. So we click on File, on New. We set our database name, which is piston.db, and we select the folder we want to save all the information. And in my case, it's Piston1. I select the folder and I click open and OK. After that, we want to make sure that based on model tolerance is selected and also that our analysis is structural. Now we're gonna import our solid, so we click on File and Import. This is a parasolid model, so the source needs to be parasolid XMT, and we select our model and we click Apply. When the summary pops up, we click OK and here it is. This is our piston. So after that, we are going to create our material. So we click on Properties. This is an isotropic material which name is steel. We're going to input the properties. The elastic modulus is 30E6 and the Poisson ratio is 0.3. We click OK and apply. The next step is to create our 3D solid. So we click on solid in the 3D properties. The name is Piston, and we're going to input the properties selecting our material name, which is steel. We click OK, and the application region is our entire model. We click Add and then OK and apply. Now our model is ready to add the constraints on. So we click on Load and we add a displacement nodal constraint which name is Fixed. We input data and we add a vector of 0, 0, 0 in order to have no movement at any axis. We click OK and the application region is our pinhole. In this case, both pinholes. So we select the first one and we click Add, and now we select the second one and we click Add again. OK and apply. The the blue numbers are our constraints, and now we're going to add a pressure force, which name is Piston underscore pressure. We input the data. The value of that force is 1200, so we enter the data. We click OK, and the application region is just the top face of our piston. We click Add, OK, and apply. Sorry, this is an underscore. Then we click Apply, and this is our force or pressure force. So now our model is ready to be meshed. So we click on Meshing. Since we only have the student's license, we are going to create a simple mesh, and the type is solid. And the topology is TET4. And in the input list, we are going to select our entire model. We're going to uncheck the automatic calculation in the value because the value is 0.5. We click Apply, and now our model is meshed and ready to be analyzed. So we click on Analysis. We're going to run an entire model for run, and we need to be careful with the job name. And the job name needs to be the one that we set at the beginning, and we click on subcases, and the viable load cases is default, and the output requests, we want to make sure that this option is selected. We click OK, apply, and then apply again. Nastran is running the model, so we wait till it has results. When the black window goes out, now our model is ready to be attached by an XDP result. So we select XDP and we make sure that the job name is the one that we set at the beginning again, and we click on apply. Now we're going to watch the results. In the fringe result, we select the stress tensor, and on the formation result, we select displacement translational. We click apply, and those are our results. As you can see, the red sections are the ones that have the biggest stress forces. So this helps us to identify where is our critical area, which is under the highest stress. Thank you for watching.